Hello, we are on 9.5 series, and a series is a sum of a sequence. Okay, hold on, I think I got something on my pen. All right, sorry, I had something, who knows what, on my little tablet. Okay, a series is a sum of a sequence. So the sequences that we talked about in 9.4, if we added them all up, that would be known as a series. And series uses summation notation. You've probably seen this before, and probably in a movie where they want to make math look really scary. Um, but here's what we got. So let me go through every piece right now. Hopefully you have it written in your notes already. That would be lovely. The first thing I want to point out is that this symbol right here, oh boy, is known as sigma, and it means to sum or add up the following things. Add up the following. The next thing I want to point out is this piece right here, this a sub k. This is going to be the explicit definition of a sequence, whatever sequence, obviously we want to add up. Then we've got these two pieces here, the k equals 1 and n. This is telling us where we want to start adding, and this is where we want to stop. So in this case, k equals 1, that would be a sub 1. That means start at term number 1 and end at a sub n. And so start at a sub 1, term number 1, and end at a sub n, the nth term, whatever that would be. That is our notation for a series. So let's try using that notation. It says write the following using summation notation, assuming the suggested pattern continues. So the first thing we need to figure out basically is this, what kind of sequence is this, and is it arithmetic or geometric? So we'll start with the first one. I look at this and I think to myself, either what can I multiply 2 by to get 5, or what can I add to 2 to get to 5? So 2 to 5, I would be adding 3. And then I check, is that the same for the next one? 5 plus 3 is 8, and then 8 plus 3 is 11. So I look at this and I can tell it is arithmetic. And specifically, it's arithmetic with a common difference. I am adding 3 every time. Okay, so then I need to figure out what is my explicit definition of an arithmetic sequence. Now, we had this in our previous section, so hopefully you can flip back in your notes. A sub n is equal to a1 plus n minus 1 times our common difference of d. All right, for ours, a sub n is our first term, a1 is 2 in this case, plus n is still our variable, minus 1 times our common difference of 3. All right, we can simplify this a little bit. I'm going to distribute the 3. So I get 2 plus 3n minus 3, or 3n minus 1 is our explicit sequence. Okay, so that's great because that gives us pretty much half of our problem. All right, just made things a little more manageable. So we are, like I said, we have a lot of what we need already. So we are going to find the summation of our explicit definition, so 3n minus 1. And we're starting at the first term, n equals 1. And this is the term we are ending at, but it's not necessarily the 53rd term. We need to figure out what term number this is, right? So we have some term, let's say an, is equal to 53, the nth term. Well, what term is that? We can use our explicit definition to help figure it out. So I'm going to set this equal to 3n minus 1, and I'm solving for n, or the term number that this is. So I'm going to add 1 to both sides. 54 is equal to 3n, and then divide by 3, and I would get n, equals 18. Or that 53 is the 18th term, which means I'm going to put an 18 up here and I now have this sequence written as a series. I am adding up the terms from the 1st to the 18th, and this is my definition. All right, for this next one, I notice that it's switching between adding and subtracting. I am not going to get that by adding the same thing to a number. I'm going to get that by multiplying. So I consider, what would I do to 5 to get negative 15? Well, I'd be multiplying it by a negative 3, and then if I multiply negative 15 by a negative 3, I'm going to get a positive 49, and so on and so forth, which means my common ratio in this example, which is a geometric, is negative 3. Now notice a couple things about this one. We are adding up the values. We're going to assume this is 1 from n equals 1. But notice it has a dot, dot, dot. So I am adding up not to a certain term, but technically every term. So from the first term to infinite. And now I just need the explicit definition of a geometric random variable, which if we follow our formula from last time, is the first term times r, which in this case is a negative 3 to the n minus 1. And that is our series written in our summation notation. Lovely. Hope you enjoyed as much as I did. Here's our next problem. Calculating the sum of a given series. So notice, again, we have what term number we want to start at and stop at, and then our explicit definition of a sequence. Now this is not geometric or arithmetic. I know that because it doesn't follow the forms that we just saw on the last slide, but that doesn't mean it's not a sequence. In this sequence, we want to add up the first, the second, the third, the fourth, and the fifth terms. How do I know? Again, because we are starting at A1 and we are stopping at A5. And this term, or excuse me, each term is defined by squaring the term number. So 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. Now, obviously, you all know how to square and add these things. I'm just going to help you out. When you find the sum of these values, you are going to get 55. And that's really all this problem was asking you to do. Again, a smiley face. This section comes with a lot of formulas that'll help us find sums more quickly because although what we did on the last slide was not necessarily hard, it's not always something we want to do. I don't want to add up a bunch of terms if I don't have to. So what I'm about to tell you is a formula for the sum of a finite arithmetic sequence. There's a lot of important words here. I want to start with arithmetic. We know our arithmetic sequences are adding or subtracting. So I'm going to just say adding a common difference of d. And finite is obviously not infinite, means that this sequence has an end point. All right, so this would look like if you are given something that's, let's say, k equals 1 to n of a sub k, which would mean I'm adding the first term plus the second term plus all the way up to that nth term. That's what this is going to look like. Well, how can I do this? There is a formula to do this, and I'm going to give you two different versions of it. The first is we're going to say n, the number of terms, times the first term, a1, plus the last term, a sub n, all over 2. This is one version of the sum of a finite arithmetic sequence. However, we could write this slightly different because this a sub n we know the formula for, right? If this is an arithmetic sequence, oops, that was supposed to be a Q, sequence, then a sub n is really equal to our first term, a1, plus n minus 1 times the common difference of d. So if I take that information and put it in right for this, I really have. Now I'm gonna do two things at once, so please stay with me. I'm gonna pull this 2 out, so I'm gonna have n over 2 times a sub 1 plus, now instead of a sub n, I'm gonna write this formula, a sub 1 plus n minus 1 times the common difference. I don't really like how that looks though, so let's simplify. Specifically, I'm just going to add up my a1s. So I could also write this equation as n over 2 times 2 a sub 1 plus n minus 1 times the common difference. And of course, you could multiply that common difference into both terms if you want. I just want to point out that there are two versions to do this. Why is it important to notice that we have two versions? Well, notice in this second version, I don't need to know what the last term is. I just need to know the first term, how many terms, and the common difference. In the first, I need the first, the last, and the number of terms. So depending on what you're given, you might use one of these two different formulas, again, for the sum of a finite arithmetic sequence. So let's try it. The corner section of a stadium has 6 seats along the front row. Each successive row has 3 more seats than the row preceding it. If the top row has 24 seats, how many seats are in the entire section? All right, so let's figure out what we know. We know that our first term, a sub 1, is 6. The corner section of the stadium has 6 seats along the front row. Each successive row has 3 more seats than the last. That means my common difference, I am adding 3 every time. Okay, that also tells me it's arithmetic. Arithmetic. And we are told if the top row has 24 seats. So that's some unknown term, but I do know that it has 24 seats. We need then to find the number of seats in the entire section. All right, so I am summing up an arithmetic sequence, specifically one that is finite because it starts and stops. So I know that the sum is equal to n over 2 times a1 plus an. All right, sorry, I had to step away. Something loud fell and I don't know what it was. But here's where we were. We know the first term is 6. We know the nth term is 24. We know that the common difference is 3. We know it is arithmetic. And here is our general formula for the sum of a finite arithmetic sequence. Okay, so we have a 1. We have a n. But the issue right now is we don't know how many terms there are. We don't actually know what term that is. Well, don't worry. We are super smart. We can find it. How? With our explicit formula for an arithmetic sequence. So any term is equal to the first term plus n minus 1 times our common difference, which means 24 is equal to our first term, which was 6, plus n minus 1 times that common difference of 3. I'm not going to show you all the work for this because you guys are really smart and I know you can get that, but we're going to solve and get n is equal to 7. You could have also, I just want to point this out, you could also go a1 is 6, plus 3 is 9, plus 3 is 12, and keep going all the way to 24 and count how many terms, but honestly, that's probably going to take you longer. Bottom line, we now know our n, so the sum of this sequence is going to be 7 over 2 times the quantity 6 plus 24. Now don't get your calculators out right now. 7 over 2 times 30. Well, what's 30 divided by 2? That's going to be 15. And 15 times 7. 7 times 15. Well, this you can maybe get your calculator out for if you want, is 105. So the final answer, there are 105 seats in this stadium. All right, I think that's where we're stopping for today. Let me just verify. Yep, that's where we're stopping for today. Ask questions, obviously, if you need, and I will see... Well, I will not. Okay, that's really sad. I won't see you guys soon, but I'll talk to you soon. Okay, bye.